Hey guys, this is Surya from Skill-Lync. Hope you're doing well. So I'll kind of quickly give you an overview of what this session is going to be. This session is intended to answer a lot of your queries with respect to skill development, how to get jobs, what kind of roles that are available in the market, and so on, right? One of the things that I wanted to do in this half an hour to a 1 hour conversation, I wanted to keep this conversation on a multi-direction. Essentially, I want you to also ask questions so that it becomes very communicative and interactive. So that's essentially what we want to do. Let me kind of give you a quick overview, right? So Skill-Lync is an online platform providing courses, job leading courses in mechanical, electrical, electronics, civil, and computer science engineering domain. So essentially, the whole of engineering, right? So we have a multitude of courses. The goal for us at Skill-Lync is to kind of bridge the gap between academia and industry, right? What do we mean by that? So in our college, what we learn is a lot of theory, right? But when we get into the industry scenario, what they expect is applying the theory in using any computational tools, and that theory should be applied for practice solving practical problems, right? And that's a whole reason we started Skill-Lync, right? A lot of people in mechanical engineering, when they think about mechanical engineering, they think that okay, mechanical engineering is a lot of hardcore kind of hands-on things. And but the industry as a whole, the mechanical engineering, automotive, aerospace, rail, infrastructure, every industry, the engineering aspect of the industry over the last 2 years has become more computer aided engineering. So what do I mean by computer aided engineering? So there is a tool that helps engineers design their ideas, simulate their designs, and also even before making the product, understand how good the product is and how durable the product is. There are multiple things that you can basically look into product before manufacturing the product, right? um, so yeah, this is essentially what Skill-Lync is trying to do. Skill-Lync is trying to do, trying to provide you knowledge in the area of computer aided engineering. For if you take a mechanical engineering, every subdomain of mechanical engineering we basically focus on. So now the question is, there are a lot of questions, right? I have been looking into the questions that have been coming in. There are a lot of questions. Most of the questions that I have got is, how do I choose a particular domain? That's one of the first questions that people ask. Then they ask, what is the job scenario right now? Then there is more questions about how to kind of get those jobs, right? So let me kind of ask you a question right now, right? If I basically say, give you three options. Option A is, say, to kickstart this meeting, if we basically say there are three options, and we will start with one option. Option A is, hey, I'm in mechanical engineering and I want to kind of understand what are the different domains that I can bridge my career into. All right, can you give me an overview of different domains that I can bridge my career into? So that's option. Option B is, hey, I'm pretty sure I focus on one particular domain. It can be design, it can be CFD, it can be FEA. What are the job opportunities that are available right now? How do I, given that COVID is again rising in numbers, how do I make sure I kind of target my efforts towards a job that helps me pursue my dreams, right? That's option B. Option C is essentially, okay, how do I apply for these jobs, right? So option A is, what are the domains? Option B is, yeah, I know a particular domain. What are the jobs available in different domains? Option C is, what are the different jobs available and how to apply? So if you can let me know what you guys would be interested in starting, right? Of course, yes, all options. That's the goal. B A B B and C, B and C, all options, B and C. Okay. So looks like there's a mixed response, right? So let me kind of do one thing. I'll kind of kickstart the meeting with a slightly say option A. So I'll cover all the three aspects of it, and as we kind of cover these three aspects, we can basically I can take any questions that you guys have. I'll kind of take one step back and say this is not a workshop, this is not a webinar, this is more of a ask me kind of anything, any question that you have. So the goal of this particular session is to kind of answer most common questions that you basically have. And based on the questions that you had asked before, we have come up with these three. And from these three, you can basically ask me any of those different questions that you have asked me, right? So as I kind of kickstart this, so let me kind of open up a Word document and share that Word document, and kind of in that Word document, I'll kind of start sharing my screen and also my thoughts as well. Part A, let me say part A, right? Part A is what are the different opportunities available for mechanical engineers, right? And if I basically take this question one step forward, what I would basically say is not only mechanical engineers, what are the different opportunities available for mechanical engineers in different domains of engineering, right? So let me kind of state this as the first question. And as we kind of start, one of the things that I would say is, say, you can think about mechanical engineering as a product itself, right? And what do I mean by mechanical engineering as a product? So whenever you take a product, right now you might be looking at this AMA through a phone or a laptop, right? And when you start thinking about a product, the first thing that you know is basically design, right? Once you design that, then you basically want to, based on the product, you want to analyze, right? Analyze. So let me say is analysis, and then probably prototyping, and then manufacturing, right? So now if you basically think about this from a product aspect of it, you will understand, okay, first you need to you will have an idea and you essentially design that. And when you design that, and if you design it, you want to understand if your design is stable, right? If your design can be can withstand some different forces, right? That's analysis. Then you want to kind of do a small prototype, that's prototype phase, and then manufacturing, right? And if you basically take a look at this, right, design, under design you will basically look into ideation, right? And then in ideation, after that you will basically look into product development itself. And based on your product, right, it can be a sheet metal, it can be a plastic, it can be surface modeling, say for example, uh, surface modeling. It can be solid modeling, right? So these are the different aspects of design, right? Like if you basically look into product development, then you will this four will definitely be the more general perspective, right? Now, out of these four, say you are looking into a particular domain itself. What do I mean by domain? Say, for example, you are developing a product for automotive, right? So in automotive, say for example, you might have a seating system, then you will have a lighting system, you will have say wiring harness. You guys can also contribute to this if you know a few things. I have my chat window also open, so you can essentially enter things that you know. I'll also add it if it is uh, appropriate. So you have BAW, so door panel and all those things comes into the trims and the plastic, right? Seating, lighting, then wiring harness, BAW, then your chassis, powertrain. So This is in what do I mean by BIW? BIW is called body in white. Say usually contains your roof of your car, your fenders, your back doors, and say probably and in when you speak about doors, back door, front door, side doors, etc. B pillar, C pillar, A pillar, all those things kind of comes into play. Then probably your floor, right? So essentially, when you take up design, right, and in ideation is where you basically, so if you're looking into sketching, right, say sketching is where you basically do clay modeling, say clay modeling, surface sketches, and much more, right? So essentially, if you even before getting into the product development stage, there is a detailed ideation stage where you basically sketch your idea, right? And then the sketch kind of translates into your product. So probably it might be your master section that kind of gets. So you're sketching to product development. Now, so if you basically look into the product development phase, you have say four major components, and you these four major components are used in different ways in different sections of these automotive components, right? A seating system might use surface modeling, solid modeling, and sheet metal. A lighting might use a lot of surface modeling. A wiring harness is more of solid modeling and electrical wiring harness. Then you have your BIW, which is more of sheet metal and a little bit of surface modeling. Trims is a lot of plastics. Chassis and powertrain again comes to surface and solid modeling and sheet metal. So one of the aspects of product development is to understand, okay, the whole design process, sheet metal, plastic, surface, and solid. The advantage with fitting a particular application. So let me say design is a domain or a subdomain, and this is an automotive is an application. The advantage with picking up a particular application is that you apply the fundamentals, which might be sheet metal, plastic, surface modeling, and solid modeling on an application. So when you do that, you understand what is the manufacturability of a particular component. A sheet metal can do a particular type of bends, particular type of patterns, particular type of chamfer will be available. So you will understand all of that only when you essentially apply that on an application, right? So that is why this is very important. So this application can be different things, right? Say for example, it can be aerospace, it can be rail, it can be heavy duty trucks, right? Essentially, it comes into and any other products as well. Yeah, defense, right? So essentially, one of the understanding of this four aspects of it. But if you think about it, every component that you see in your daily life will be these four, based on these four aspects, right? And that's essentially, then you basically pick a application, and using those application, what you understand is, if you work really well on one application, your ability to transform from one application to another application will be easier, because you understand, okay, in automotive aspects of it, these are the fundamental principles. Okay, aerospace, the principles might be different, but the manufacturability might be same, fundamentals are still the same, right? So this is your design phase. This is what I would call your design phase. Say, for example, once you design this, right, then based on your product, right, what will happen is there will be different types of analysis. Say, I'll kind of right now stop at 3, and FEA is finite element analysis. You guys can ask questions as well. If you have any questions here, I will be able to answer those questions as well. CFD is computational fluid dynamics, and MBD is multibody dynamics, right? So what does FEA do, right? Like FEA, what are all the things that kind of come into FEA? I'm going to take an example and then speak about it. I'm going to take an application. and for this application, say if your application is automotive, right? So crashworthiness is something that people do. So crashworthiness is essentially taking your whole car and car or any automotive passenger vehicle and impacting it from the front. So going through a frontal crash, side impact, roof crash. So all those things can be simulated, right? Essentially, it is called as explicit dynamics, right? So this is one aspect of it. Then exactly, somebody said NVH, noise and vibration harshness. Then there is something also called as, so where do noise and vibration harshness come into play? Say for example, your you have a, there are two to three types of NVH analysis. Say for example, you're having an engine. So if the engine is producing a lot of noise, then you need to also kind of take into account, okay, how is the noise? Is the noise at a harsher rate to the passengers inside the car, right? And how do we control that? So that's one type of analysis. The other type of analysis is also modal analysis. NVH can also kind of go a little bit into modal analysis as well. But yeah, so that's a great example. So if you basically take a look at NVH, then there is modal, thermal, harmonic, static structural, static and dynamic structural, and much more, right? So there is a lot more out here. I haven't covered that on entirety, but say for example, in general, FEA, which is structural analysis, has things to do with the structural aspect of it. What do I mean by that? Any force that is impacts the structure will basically come into finite element analysis, right? The stresses caused by stresses or deformations caused by a structural force is essentially comes into the FEA aspect of it. Then comes your computational fluid dynamics. So in computational fluid dynamics, there is multiple different aspects of it, like turbulence, or so multi-phase flow, two-phase flows, and much more. But I'm not going to go deep into CFD, but what I'm going to kind of give you as an example is aerodynamics of a car, right? Is a great example of computational fluid dynamics. So that's the external fluid dynamics of a car, is also called as aerodynamics, right? Then gear sloshing, right? So how does gear sloshing happen? So how does the lubricant inside a gearbox slosh in order to make sure the gears are well oiled, right? So all those aspects of it are examples or of applications of CFD. MBD, multibody dynamics, as the name suggests, is multiple bodies connected together. Understanding the dynamics of multiple bodies connected together when a force is implemented is essentially multibody dynamics. A great example is vehicle dynamics, right? So suspension kinematics, kinematics, steering kinematics, how does your tire simulations, and all those aspects of it come into multi-body dynamics. Again, these are very, what I provide right now is a very few example. It does not take into the entirety of all the applications, but I'm just, the reason I'm kind of giving you applications is to kind of give you an idea of where you can look into, right? So I'll also, as I do this exercise, I'll also come back and say how you can choose your, how you can basically say, okay, this might be my area of interest and I can basically try this out, right? So the other aspect of it that is kind of coming up is electric. I wouldn't say electric vehicles alone, but I'll say the whole aspect of it as electrification, right? So because we are speaking about automotives, electric vehicles, you have how does the controls work? What is a battery management system? um, BMS, so controls, BMS, what does DC motors do, um, and then much more, right? So essentially, if you are looking into something like electric vehicles, you need to understand the fundamentals of electrical and electronics engineering, such that you basically have the ability to bridge your mechanical engineering knowledge with the electrification aspect of it as well, right? It can be the electric vehicle architecture, or electric or hybrid or HEV architecture, and etc. Right? So once you do this, where does prototyping come? So prototyping, one of the trends that is kind of picking up over the last 3-4 years itself, or probably for the last 5-6 years itself, is additive manufacturing, right? Essentially 3D printing, yes. So what does 3D printing allow you to do? Additive manufacturing allows you to kind of build prototypes very quickly, so that you can essentially test it in the lab itself, right? Once you're done with your CFD and FEA, CFD, MBD, whichever analysis that you want to do on your component, once you do that, if you want to kind of do additive manufacturing, it allows you to 3D print and then go from that, right? Then in the manufacturing sector, you have multiple aspects of it. So if you are someone who wants to go into manufacturing in the previous years, right? Say in probably 2000s, what manufacturing meant was how can the production be done? What are the production techniques? It is still that, say, but it is not only constrained to that. Say, for example, supply chain becomes very important, right? So supply chain, say for example, is important because all the components are not built by one manufacturer. A manufacturer has multiple suppliers, and understanding the supply chain, understanding the quality of the supply chain allows you to say, okay, these are good quality components that I can basically get from the supplier and manufacturer. But what I simply say as good quality components, you need to start doing that on a more mathematical way, right? What does mathematical way mean? Say, what is the so that's where Six Sigma and all those aspects of it come into play. So if you are looking into manufacturing, do not think about it just as manufacturing. You have supply chain, or you have manufacturing design. What do I mean by manufacturing design? So there is, in product development, that is one design. Then in there is manufacturing design. So this is where you essentially build your tools, right? So essentially tool design, mold design, fixture design, all these aspects of it come into the manufacturing spectrum as well. So supply chain, manufacturing, quality. Yeah, so largely I would basically, am I missing something in the manufacturing? Let me do automation as a separate segue itself, right? Automation. Gaurav, vendor development essentially comes into the supply chain aspect of it. So manufacturing design, manufacturing processes. So let me kind of say manufacturing design, manufacturing simulations also. So nowadays, what people are starting to do is essentially there is assembly line simulations, there is manufacturing simulations, there is mold flow simulation. So mold flow, say if you're interested in manufacturing and also in computational fluid dynamics, mold flow simulation is a great way to kind of enter into the industry. So something to think about as well. Yeah, cam and all those aspects of it will kind of come into the manufacturing design, tool design, mold design, and fixture design. Great. So now let me kind of take a step back, right? So now we have kind of said, okay, there is design, there is analysis, there is prototype, there is manufacturing, and probably there is automation as well, right? So how do I basically pick a particular domain, right? So here's again what I'm going to explain right now is might be very crude, But this is something that we have tried and tested it out on a lot of engineers, and it has worked, right? Say, for example, if you are someone in the, let me start with analysis, right? Because this is the easier part of it. Say, I'll go here. I'll kind of start up separately. So let me kind of start with analysis. So if you are someone who is starting up with analysis, right? What it means is you have either, come on. If you start with analysis, you have, let's say, FEA, CFD, MBD, and electrical. So how do I basically say, okay, I like, and say, if you are someone who knows what FEA is, what CFD is, what MBD is, what electrical is, and you know a particular, this is the domain that I want to specialize, that's great. You are already in a great place. Go ahead and do that, right? But if you're someone who does not know, one of the main things that I will say is, for all of these things, one common aspect of it is math. So being good at math will be very, very helpful. What do I mean by math, right? So having an understanding of matrices, calculus, right? These two things help you a lot if you want to be very, very successful, like very, very successful in an engineering stream itself. And what do I'll explain as I go by it. What I mean by, if you want to be very, very successful in the engineering stream, right? Then how do I choose if I like FEA? So if you like these subjects, strength of materials, SOM, solid mechanics, obviously as the name suggests, finite element analysis. So these are the fundamental subjects. At least these three subjects become very fundamental for you if you want to get into finite element analysis as a career. These three together with math allows you to build a very, very strong career. I'll explain. Say, for example, if you have strength of materials, good understanding of finite element analysis, solid mechanics, and strength of materials, right? The job roles you can apply for are, say, modeling. So what they call as modeling engineer is essentially meshing, right? You can be a structural analyst, FEA engineer, modeling. So any model building, again meshing. So based on if you are able to work on crash, NVH, more model and those kind of things. So essentially you will become a crash or NVH engineer. FEA software developer slash FEA automation engineer. So all these comes when you're very good at math. Okay, so this is FEA aspect of it, right? If there is any questions, I will be happy to answer them. You can post it on the chat box. So your questions can be at different levels. Say, for example, you can ask me a question on how to grade approach. Okay, great. So if you are, how does career be in the, so Surya, I cannot understand your question. If you can explain this in detail, I can help you, right? So if you want to get CFD, right? Second, math, as I said in the beginning, for all analysis, math becomes very, very fundamental. Same matrices and calculus. So one of the things that our education system does not do, which is very, very sad, is it does not explain us the importance of math with respect to all the FEA or CFD. What we learn is we learn maths 1, maths 2, maths 3 in different semesters. We learn integral calculus or matrices at a different segues where we do not connect FEA or we do not in a maths they don't teach us about stiffness matrix that FEA basically looks into. Jacobian, while they teach Jacobian in matrices class, that Jacobian and fluid mechanics is not kind of interconnected, right? So that is the drawback. But if you are able to do that connection, if you are someone who is able to do that connection, then you have a very strong career as a software developer, right? So that's your advantage. So math, say here fluid mechanics. Prashant is asking a very good question. After acquiring all these skills, how can I get a job? Because all companies are hiring from IITs and NITs. I will park this question right now, Prashant, and answer this question at the end of the segment, right? I'll definitely answer that. Very important question. Heat transfer, thermodynamics, then jet propulsion, gas dynamics and jet propulsion. TOM, sorry, I don't remember what TOM is. A theory of machines, is that what theory of machines, is that what you're basically saying? IC engines, yeah, great. Popular ready IC engines, yeah, all those aspects of it, right? So these are, say, CFD, right? And CFD, essentially, the fundamentals that I would say, there are a lot of you who are basically speaking about IC engines, turbo machinery, and so on. Definitely, right? Those are applications, I would say, but the fundamentals for you to get into computational fluid dynamics is these aspects of it, right? Again, what are the job roles, right? If you basically ask me, Surya, this is great. What kind of job roles that I can apply for, right? Here, say, if you know math well, you can basically become a CFD software developer, CFD automation engineer, right? Apart from that, say CFD simulation engineer, right? There is multiple aspects of it. So with say if you are looking into the EV domain, say BMS, battery thermal simulations, then electronics cooling is a field that is kind of coming up with all the whole industry is moving towards electrification, electronics cooling, EV battery thermal simulations, aerodynamics simulation. Then there is another aspect of it which is also called as model building, same machine but for CFD. Right. So these are the few areas. There are multiple other areas. I'm just not getting into everything, right? So these are few areas. Say for example, model building, aerodynamics, model building, electronics cooling, battery thermal simulations, CFD simulation engineer, CFD software developer. They have multiple different applications, right? Say for example, when I say multiple different applications, turbo machineries, IC engines, electric vehicles, your products like servers, database management servers, computers, laptops, all electronic gadgets, all of these things also use computational fluid dynamics. All right, so something to think about. So again, at MBD, you have your so math becomes very important. Then kinematics of machinery, KIM, becomes very important. How to deal with mechanical aptitude in job interview. Okay, there are very good questions that are coming up. What I will do is I'll basically finish this aspect of it and then kind of jump that, right? So kinematics of machine engineering mechanics, right? And out here, if you basically look at the job roles, so here's where if you're good at this, vehicle dynamics engineer, powertrain, suspension design, suspension engineer, and much more, right? So these are a few. Um, in electrical, as mechanical engineers, what you will do is you'll basically get electrical slash FEA roles, electrical slash CFD roles. So these are the kind of roles that you will be looking into. So if you are someone who is generally interested in electrification, electrical machines, and all those aspects of it, and if you have either FEA, CFD, or even the multibody dynamics aspect of it, what you can essentially do is have two specializations and build a way to kind of combine that. So KM is kinematics of machineries, Abhishek, right? So here's the whole aspect of it, right? So let me kind of now take a step back and answer a few questions that a lot of you are asking, right? Let me kind of see about those questions. Pratik Raval, can we build a career as a freelancer in FEA? See, a lot of the companies that do FEA analysis, right, are automotive companies, right? FEA, there are a few all the product companies do FEA kind of analysis because they want to understand what's the structural stability of their component. And when they look out, say they either have their in-house capacity or they look out for vendors who can do that. And that vendor essentially needs to be someone who is reputed in the industry. As a freelancer, you will get small projects but not big projects unless you become really, really good at it. Right? If you are becoming very, very good at it, so if you're very strong at math, if you're able to build models, right? If you're able to build macros that automate meshing, if you're able to build macros that automate a solver, right? Then they will definitely come to you. Or if you're able to automate the post processing using Python or TCL/TK, then they will definitely come to you. But you need to be the best in that domain in order to become a freelancer and also get really good projects, right? Pratik, that's one of the aspects of it. So Prashant, after acquiring all those skills, how can I get a job? Because all companies are hiring from IITs and NITs. Very, very good question, right? So if you basically think about the hiring structure in India, what these companies do is they basically go to tier 1 colleges, either your IITs, your NITs, or some of the best bids, those kind of colleges, and hire, because the companies are looking for the best minds that can be trained, right? It does not mean these colleges have all the application oriented knowledge, but they are looking for best minds that can be trained. That does not also mean there are not there are not there are no best minds outside these colleges, right? So I studied in a tier 2 or tier 3 college, and I know for me personally that the top 15 to 20 percentage or even 30-40 percentage of all the engineering colleges have really good talent. Now the point is lack of exposure. So what does lack of exposure do is, say for example, if Surya is in a tier 2 college, even if he's in the top 5 percentage, since the companies do not come to this college and recruit, Surya does not have an opportunity to get exposed to those companies. Now what does Surya need to do? Surya needs to develop a portfolio. Since the world has digitized, Surya needs to develop his own portfolio that can be showcased across different platforms in social and recruiting platforms that can grab the attention of the recruiter and provide him a job opportunity. I'll give you an example, right? Let me kind of go out here, and so say let me kind of show you something. So one of the questions was how can I take a skilling coursework and get exposure and jobs, right? So every skilling student who goes through a coursework essentially gets into this platform, right? Say for example, if you're a mechanical engineer, so there is electrical, civil, computer science, I'll kind of go into mechanical. So what happens out here is, say Jeti Dinesh or Aman Kumar or Anish Augustine. So what I can do is, if I'm going to look at Anish Augustine, right, I can see his profile, and what are his domains that his software. More importantly, I can see the projects that the student has worked on. Now, if I am a recruiter, what I can look into is, okay, what drop test challenge has Anish done, right? Then I can also see, okay, bird strike project. What has he done? What is the stress concentration on a plate? So when I basically go through this and go through a report where Anish has explained the way that he has done a particular simulation, I can understand, okay, this is the background. So Anish does not have only the tool knowledge, but also understands what is the governing equations behind this particular problems, and has the ability to demonstrate in a very detailed way how he has done the simulation. Because in an industry, this is what they look for, right? This is essentially what reports look like in an industry. And if somebody is able to do this, right, they will be looking for people like this. So exposure, the problem of exposure gets solved when you have a portfolio full of projects. The problem again with Indian engineering colleges is you only do two projects. You do a final year project and a pre-final year project. And although some of the times your pre-final year project is copied from your senior, borrowed from your senior, your final year project is an industry project where you're not doing anything of significance, right? Or you are not learning as a result. What happens is that you do not have a very strong portfolio because of that. Say, for example, here, right? This is a simple project. This is not a very complex project, but the ability of Anish Agustin to kind of explain this project in detail allows him to showcase his portfolio. This is how you basically get exposed. There are two things, right? Like, I'm reading a book called Can't Hurt Me. I don't know. I actually had that book here. That book essentially says, you guys can Google this book. It's called Can't Hurt Me, right? It's by David Goggins. We can basically give reasons um, for not succeeding, but all those reasons essentially are reasons, excuses. If we are putting ourselves into a place where we put in a lot of effort in order to succeed, right? We can change the notion that only IITs and NITs have good jobs. Right? Actually, there are a lot of mechanical engineering jobs in the country. There are not enough good mechanical engineers who can apply for these roles. See, for example, if you essentially go to skilllinks.com/projects, you will see students showcasing, say, all you need to do is search for hashtag skilling projects. You will see students showcasing their projects, right? And what happens due to this is they're basically using the link and everything, right? What happens is they are getting exposed to the world, right? So this allows students to showcase their profile to the world, and this is the exposure that I wanted to kind of speak about. Right? Let me kind of get back. So Prashant, to answer your question, if you have the right portfolio, and if you apply very in a very strategic way, your ability to get jobs is definitely high because there are a lot of jobs available in the market. So it is not only IITs and NITs, there is a lot of jobs. Jobs are looking for people who are able to get, who are able to have the right skills. If you are able to expose that, that would be great. Jayesh, does EV domain decrease the application and scope of CFD? It has, since after removal of IC engine simulation using CFD, it has left only few applications such as aerodynamics, as battery thermal management, and internal fluid flows. So Jayesh, as you know, IC engine is a very old, mature technology, right? So it came in the 1900s, and even after 100 years, there is so much new innovations happening inside the engine, right? And that's why CFD is getting better day by day. CFD is allowing IC engines to get better day by day. Very similarly, your batteries and battery management systems are, while the idea is also old, the mass market adoption is happening now. So you can think about how Ford adapted IC engines Tesla is adapting batteries in electrification of cars. And over the next 100 years, there will be so many iterations of the battery, so many iterations of the whole system of powertrain that is going to be used in order to make it more efficient. So computational fluid dynamics will only grow as a domain that allows people to research more and get better at things. So I don't see CFD kind of expand. So until fluid is there in the world, so which is essentially your any fluid is there in the world, there will be computational fluid dynamics. So you can basically think about it in such a way as well. Prashant also has, how can I work industry projects while learning these skills to enhance and accelerate to the next level? Uh, so Prashant, there are a lot of platforms where you can work on industry projects. Like SkillLync is known for working on industry projects. So even when you're working, you can essentially work on industry projects or from different domains, right? Even though having zero knowledge about design softwares, can I take the course and get the job? If you are able to kind of put in the efforts, Jagadish, I think you will be able to do that. Okay, tell me about design, right? You said Mateen Mary model, is it different from both domains? Mateen, I don't know if you are here, but yes, Mateen's question was, you said about model building in both FEA and CFD. Is it different from both the domains? The principles are the same. The way the meshing is done for CFD and FEA are different. Dhananjay, FEA plus CFD skills have more job opportunities and career growth. I have done MTech in thermal engineering, interested in CFD domain. As I am fresher with basic FEA knowledge and CFD knowledge, will have more job opportunity now, or can you say post-pandemic, how to grow your career as a CFD engineer? Dhananjay, if you are an MTech engineer, see, CFD plus FEA is basically multi-physics, right? There is a lot of multi-physics simulations that is happening. Previously, it would be CFD simulations and FEA simulations. So right now, fluid structure interaction, FSI, is something that is gaining very, very fast significance, because a lot of your problems in practical life is both, you need to take into account the results of the structural stresses, displacements happening on the computational, on the fluid flow as well. So you basically need to combine both. Fluid structure interaction is something that is growing. So to answer your question, having a very strong FEA and CFD skill, it becomes a very good weapon for you to get a job as well. So again, you need to definitely work on fluid structure interactions as well, because those are the roles that you can apply for. And fluid structure interaction roles have a very high growth opportunity as well. So you can think about it in such a way. Which job role we can apply to enter oil and gas industry with master in FEA? Razik. So Razik, say if you look into oil and gas industry, right? So you need to first look into, if you are going into oil and gas, are you going to say companies like Schlumberger? So Schlumberger, what it does is it has its own excavation heavy vehicles, right? That's what they call it as, right? So these excavation heavy vehicles, say for example, if you're going into the oil and gas industry, in oil and gas, you need to dig into the land, right? So in order to dig, they use different kind of machines, and these machines have a lot of vibrational force. These machines have a lot of wear and tear. So over a period of time, you need to start understanding, say, if you want to get into FEA, then you need to look into noise and vibration harshness. You need to look into cyclic loads. You need to understand different modal analysis, harmonic analysis, fatigue analysis for the teeth of the gears. So those are the aspects that you need to look into, right? So something to think about, Razi. If you're going to CFD, then different aspects of it. Vishal Divedi, sir, after learning any special course and skills from Skilling, can we start a startup which would work for some company? Vishal, definitely. Again, what we have seen is, say, for example, there have been an electric company which, so people were, a few students from a college, I think VIT, were interested in developing their own electric vehicle. What they did was they took up our masters in passenger car vehicle design and then hybrid electric vehicles. What they ended up was by taking up these two courses, they ended up building their own BAW, which is the chassis aspect of it, and build a whole passenger vehicle. and the battery management systems, right? And right now they're basically building a prototype as well. So I don't see a reason why you should not be able to do that. Sai Sudhir Reddy, every company expects experienced candidate, but how can freshers overcome this? Very, very good question, right, Sai? So why do companies look for experience? So there are two reasons, right? So if you look at companies like, say, Zitadel, ESI, Axis Cadres, they are engineering service organizations. So they basically outsource engineering services for companies like Ford, Fiat Chrysler, and so on. So when these companies hire, what they look at is, okay, I need to hire a candidate who is also going to get a green signal from my vendor, who's essentially who might be Ford or Fiat Chrysler, right? So they will be the customer who needs to give a go ahead. So sometimes these customers give a tight deadline of, okay, at least 2 years of experience, right? So what happens is they want people with 2 years of experience. Now, how do you bridge those 2 years of experience? Is essentially you need to have the knowledge that they are looking for from a 2 year experienced candidate. So let me kind of share. So if you basically say you're in CAE, right? So and if I'm looking into a student like Praveen, right? I can go to Praveen and I can basically take a look at the projects that Praveen has worked on. If I am someone who is looking for a crash worthiness analyst to model build, which is meshing, right? I will take a look at these profiles and see, okay, can Praveen set up a case? Okay, he has done a case, he has been able to do a case setup. So, okay, he has been able to do this in a industry setup and has written a detailed report and has got inferences as well. So this allows me the confidence as an interviewer to call you for an interview, right? But what happens most of the times is that in the interview they ask fundamental strength of material questions. Tool test, so we have seen this with skilling students as well. Tool test, they clear technical questions. Where they lag is the fundamental strength of material, fundamental fluid dynamics, fundamental vehicle dynamics questions. That is where our students lag. Not only when I say our students, general mechanical engineering students lag, right? Understanding the fundamentals is very, very important. So if you are a 2 years, the industry is definitely asking from 0 to 2 years experience because they do not want to spend time on training people, right? That's why they ask for experienced candidates. But they are, think about it, right? Like say from an industry perspective, for a 2 to 3 year old guy, they are going to give anywhere between 35 to 40,000 rupees. For a fresher, they are going to give 25 to 30,000 rupees. If they are able to get a fresher who has the knowledge of a 2 year experience, they will prefer a fresher, right? So that is what you need to focus on. If you are able to get that skill set even before you get into work life, your ability to kind of get those jobs becomes very high. Again, the way you can get you all these things will get you an interview. You need to be fundamentally strong, and that's why at Skilling we also right now are focusing very, very strongly on teaching you fundamentals as a like frequently asked questions for an interview itself. All right. So, Sai Sudhir, I hope I answered your question as well. Tamilasan, I have heard that you are providing internships. What about that? Will the candidate work for the direct companies and take their live project? Because I have seen in LinkedIn who took up, they are mentioning intern at Skilling, not mentioning at specific companies. Tamilasan, this is a internship at Skilling. What SkillLync has done is SkillLync, over the period of SkillLync, which is the last 3 years, we have now worked with around 850 experts in the industry. So what we basically understand is what are the kind of projects in the industry they are looking for. So when we provide an internship, you essentially work with the expert on an internship, right? It is SkillLync will pay you 10,000 rupees for 3 months, but you essentially work with an expert on a particular project. Say, for example, we are building an electric vehicle at SkillLync, right? Now, to build that electric vehicle, it's an electric vehicle SUV that we are building. So, as you know, you all the stages that I explained in the Word document, all of those things are involved. So our interns essentially work on that, right? So that is what people work on. So that is one example. There is multiple examples that I can give, but yeah. Sai, can aeronautical graduate have future growth in FEA domain? Sai, definitely. There is aerospace is a booming domain. Defense is also a booming domain in India. FEA in combination to those things are definitely good. Vikram Mane, which sector will have good future for mechanical engineers? Manufacturing, oil and gas, automobile, power. See, I am a firm believer in manufacturing, automobile manufacturing are kind of intertwined. I am firm believer that with the EV boom, there is going to be a lot of automotive EV power aspects of it going up in India especially. How can I grow in a design domain as fresher with less percentage in intermediate, 54%? So say for example, even if you have, here's where you need to think about it, right? A lot of companies have 60% as their entry level requirement. If you have 54%, then you need to kind of compromise somewhere. You need to start with a tier 2 or a tier 3 supplier, do really well, have gained 2 years of experience, and once you get 2 years of experience, your inter will not matter because and usually I assume inter is your 12th standard, and then you've got at least 60% and above in your undergrad. If you've got 60% and above in your undergrad, that's great because that should be fine. But if you have not got that, then essentially get 2 years experience and then go into switch to a OEM. That's the way I would go about it. Gaurav, in my exposure on LinkedIn, by talking with industry experts, they consider us as freshers, though we have done these projects, not with any competitive, and majority of them looking for candidates minimum experience having 2 or more years. Gaurav, as I explained, right? Definitely. Now, what we do at SkillLync is also we basically reach out to these companies, and when they ask for 0 to 2 years experience, we basically present profiles. And I'm speaking with some of the top engineering services organizations, leaders, and what they have agreed to is essentially they are fine with interviewing anyone with 0 years fresher experience, but they want to make sure these freshers are actually eligible and from day one they are able to deliver. So in order to deliver, the main thing is you need to be very good at the skill that you because obviously they expect a lot more from you, but you also need to be very good at fundamentals. So these are stuff that you need to take a look into, Gaurav. Jayesh, which will add more value between FEA or CFD for an undergraduate student pursuing MHEV? Jayesh, it depends upon what your interest is. Usually, if you are interested in FEA, I would suggest FEA if you're interested in fluids, because you should not do what you are not interested in. If you're interested in both, I would say FEA first and CFD second. So in the industry, there are a lot more FEA jobs than CFD jobs right now in India. Pranav, skilling course fee are quite high for us. Can you justify it? Definitely, I can, Pranav. So when you enroll in a skilling coursework, it is an 8-month program, right? And 8 months is what we have basically say. Essentially, it goes till 12 to 18 months. And if you basically see the number of people working at skilling, it's around 400 people, right? And you have a support engineer who essentially helps you. So every 20 students essentially have one support engineer. And so we, in all these support engineers do not work for free, right? So they are paid. Then we pay for our instructors as well. All the courses, the reason our courses are good is because we bring in people from the industry and we make them develop our courses. The reason that college education is not providing what you need, even after spending 4 to 6 lakhs, the reason that they are not able to provide you value is because the curriculum is outdated, right? It is only theoretical. The people who are teaching it are people who did not get a job and came into education as the last resort. And essentially, I'm not complaining, but they do not have industry experience. Since they do not have industry experience, they will not be able to correlate what industry wants and what you need to teach the students so that they are able to deliver to what the industry wants. And that's one of the main reasons why we have slacked a lot, because of the reason that mechanical engineering does not get a job in India is because they are not at all learning what the industry wants. That's the hard truth. And if we need to kind of change that, you need to have people from some of the best companies teaching you. Say, for example, we have people from Tesla, we have people from Google, we have people from Ford, right? Essentially, we pay around $180 per hour. So essentially, for every hour that they spend with us, these experts, we pay anywhere between, so $100 is like 7,000 rupees. For every hour, we pay anywhere between 14,000 to 15,000 rupees. We have 800 instructors like that. So if we need to bring quality, we also need to kind of make sure that we spend that money to provide that quality. And that being said, so we, just to kind of give you an idea, we are not like, there is not huge profit margins. Actually, there is no profit margin right now in the business, right? With respect to delivering content. But the goal is, over a period of time, as more people take the coursework, our ability to reduce the price will come. But it's like your Tesla model, right? Tesla came with Roadster. Roadster was very, very costly, right? Now Tesla comes with Model 3 where everybody can use it. But only at scale you can basically bring more lesser amount of the course price can get a little reduced. But right now, I would, the course price that you're paying is essentially the whole value is basically being delivered, right? The projects that you do, the portfolios that you build, all those aspects of it is what you pay for. AutoCAD with SolidWorks. Rohit, again, those are like, I wouldn't like to do comparisons on with respect to softwares, because software comparisons is not, it depends upon companies, right? So all the softwares right now in nowadays can do all the aspects of it. It's just the time it takes to do. Great. So Afroz is asking about design domain. Afroz, I answered the design domain at the last part of it. Obula Reddy, I hope the available teaching projects in SkillLync can be learned from YouTube or some free resources. What is the specialty with SkillLync? Obula, I would love you to show me where you can take these courses. I would definitely pay you to take those courses from YouTube. So the unfortunate thing is, with online education, right? There is, it's not about content alone. It's not about the ability of, say, for example, there are few simple things. This project that you're seeing in the screen is crashworthiness. What you will happen is, you need the software, right? You will get this software from Altair, and when you basically install it, you will get a problem. And day one, I'm just saying the smallest problem, you will have a software installation problem, right? Then after that, you will when you do the simulation, you will have a problem. When you learn about the theory, you will have a question. And the reason, this is the research, right? The reason why discontinuity in education happens is because you don't understand concepts. So the reason we have support engineers, we have around 100 support engineers. The only reason that we have 100 support engineers supporting from morning 8 a.m. to evening 12 p.m. is because whenever you have a question, there is someone who answers that question immediately, right? You take you on a Zoom call, answer your question, and get you moving forward, and then making you work on projects, building a portfolio, helping you succeed, helping you with your LinkedIn, helping you kind of get mock interviews, and also helping you get interviews, right? That is where skilling comes into play. So it's not, so first thing is, I would not accept the fact that all the aspects that we basically provide in our coursework is available in YouTube. You will not find it. You're free. You can, all the information that we basically cover in our courses is provided in our course website. You can take a look at it, and you can also search it in YouTube and check it. And if you're able to learn from it, please do it. But usually what we have seen is, it is very, very tough. Like, the percentage I would give is like less than 1% you can learn from YouTube, right? So that's why. So we basically provide a lot more things. Oh, okay. Praveen Kumar, how skilling programs courses helpful to students who are interested in MS in abroad? Like, one of the main aspects of it is When you apply for a master's, you essentially have your statement of purpose, your resume, your letter of recommendation. These are the three things that communicate how good of a profile that you have. And the way that you can communicate your profile is good is by working on a lot of projects, right? And SkillLync essentially allows you to work on multiple projects. An average SkillLync student works on at least 20 projects, right? I'll show you an average student's profile, right? I hope you still can see my screen. This is Shreya, and this is the number of projects Shreya has worked upon, right? This is the number of projects that Shreya has worked upon as a part of his coursework. This is what SkillLync allows you to do. And Shreya did not take this course after undergrads. He took it after his master's at Arizona State University, right? The reason he took it is because even after doing his MS, he wanted to make sure he has industry knowledge in order to get a job in the US. Right now, he's working in the US. So you can go to LinkedIn and also search Shreya, and you will be. So he is Shreya, right? So he works as senior design engineer, and he took our CFD master certification, right? So essentially, if you're planning to do masters, I would definitely recommend taking it up. If you're good at math, you can be very easily good at programming, so that's not a problem. Say a lot of our master courses help you teach Python, and Python for mechanical engineers, MATLAB for mechanical engineers as well. Sunil, I definitely think you can still keep on working and change your domain by. So that is where our. So a great example is Manogna. So Manogna was a mechanical engineer, passed out from Andhra, then started working as a project engineer at Wipro, and she did not want to be in the computer science domain, so she kind of took up her CFD masters and design masters, and right now she's working as a manufacturing engineer in GK in aerospace. How to apply for air traffic controller jobs? Is it well paid? How will you get help in getting funded admit from universities? Pavan, great question. Say, so let me kind of give you an example, right? Raj Dave. So Raj Dave is one of our students. He's a graduate research assistant, right? Working on cardiovascular modeling and experimentation techniques, right? And he got into Clemson University after finishing our coursework in CFD masters, and because of the projects that he has worked on, right? I can show you Raj Dave's profile as well. So this is Raj Dave's profile. Because of the projects that he has worked on at SkillLync, he was able to get that graduate research assistantship at this laboratory. Because what they asked was if he knows OpenFOAM, and he knew, and that kind of helped him get this research assistantship. May I know how do you assure jobs with a bit good pay when no other prominent universities can? So, Kutrala Kumaran, I want to kind of give you a very, very straight answer to that. I am not saying I can guarantee you a job. Nobody can, right? Nobody can guarantee you a job. What I'm saying is we have seen people succeed after a SkillLync coursework. There are multiple examples, right? All you need to do is just search for skilllyncom/placements. Right? You can essentially look at the placements that are happening on a daily basis at SkillLync out here, right? So what we have seen is every student who has taken up a coursework at SkillLync who has done really well has the ability to get a job, and the average pay is 3.5 lakhs. Now, how did they do that? They went on and put in a lot of effort in learning the coursework, and also showcasing their projects and applying for jobs, made sure that fundamentals are good, and all of this combined helps them get a job. We will help you make sure your fundamentals are good. We'll make sure you get your help in projects. All you need to do is go to LinkedIn, and all of this what I'm showing is not only I can see, right? You guys can go and look at all these things. All you need to do is search for hashtag SkillLync projects, and you will see students basically showcasing their projects, right? and this is essentially what allows students. And you can take any other online or even university, right? You will not see these many people sharing their projects anywhere else. That is the advantage with skilling. Our advantage with skilling is our ability to kind of help you work on industry projects that will help you develop your portfolio. And when your portfolio is strong, your ability to succeed is high. Let me kind of bring this into very, very fundamental things, right? You can do additions and subtraction only if you know number. You can do integral calculus, matrices, differential calculus only if you know addition, subtraction, multiplication, and division, right? Everything has a prerequisite. The way that you can apply for a job is you need to have a very strong profile. How do you get a very strong profile? Because right now in engineering colleges, what does profile mean? Well, how much is your GPA? Your GPA is 9, you're a good candidate. Your GPA is 6, you're a bad candidate. Why does a 6 GPA guy should be a bad candidate? I am a 7 pointer. Why should I not get the same opportunity if I'm able to learn what the industry wants? That's a basic question. Now, how do you understand the aspects that the industry wants? You need to work on industry oriented projects. So in engineering, we only work on 2 projects. How do we get to work on multiple projects? So this is a great example, right? Like Swaroop here is essentially worked on conjugate heat transfer of a graphics card, right? Very simple. Everybody uses a graphics card. You need to do heat transfer analysis on a graphics card. How do you do that? Right now, nobody knows that. And then these are simple problems. I'm not even saying this is a great problem to solve. These are fundamental problems. Conjugate heat transfers, fundamental problem is what he is solving. But this will look good for you because he has written a detailed report. He knows what he is doing about it, right? And this is essentially what industries are looking for. People do not do this in universities. Even the prominent universities that you're speaking about, essentially in the curriculum, they only have 2 projects, right? At SkillLync, in our curriculum itself, we have 16 to 20 projects. And that is why we are able to kind of showcase very confidently all of these things. And this is Swaroop's profile. See the projects that he has done, right? You can show me any profile and I can pick up. So design of an electric rickshaw using MATLAB and Simulink, right? Everybody is speaking about electric vehicles. How do you do that? And this is a course project. This is a project as a part of the coursework that the student is working on. And this is essentially what you need to do in order to succeed. So that's why we are very, very confident on Kutrala special offer. So what you can do is you can basically go to skillink.com, take a look at our courses. There are a lot of courses. We have an existing offer that's going on. You can essentially click on here or take a look at the courses. I think if I was an engineer passing out, or if I have a brother, and I do have a brother, and he is going through a master's in electric vehicle design coursework, I would definitely recommend SkillLync right now. The reason we built SkillLync was there was and is no platform which teaches industry relevant skills that actually help engineers succeed. We believe that in the next 3 years, 4 years, SkillLync will be de facto platform that all engineers use. But yeah, I think this is something that will be very, very helpful. Okay, one of the things that a lot of you have asked was design, right? So if you're good at, how do you choose design? If you're good at, say, general designing, if you like engineering graphics, if you like design of machine elements, if you like theory of machines, then essentially I think you will be good at design. So, and there's a lot of opportunities. India is going to boom with mechanical engineering opportunities. Over the next, you think about it, we have multi-million number of cars running in India, and all these cars need to be moved into electrification or hybrid electric cars. And that's just one field, right? We are a population of 1.3 billion people. And we need strong infrastructure, we need strong transportation systems, we need strong power generation systems. And I am very, very confident that mechanical engineers in India and Indian mechanical engineers across the world will basically be the reason for the next industrial revolution that's going to happen over the next 10 to 20 years. So if you basically are interested, I would definitely recommend taking a look at our courses and enrolling in our courses as well. If you are someone who's interested in our courses, do reach out to us. You can reach out to us at skilling.com. You can also reach out to us at 980 we can basically help you out there as well, or 8939. So this is the number you can exit, right? Great. Sounds good. Thank you so much for taking time. Have a great day. Please stay safe. And looking forward to host this session. Hope this was helpful for you as well. Great, guys. Thank you.